Okay, thank you, Stephen. Thank you, everybody. So we're going to transition into a panel discussion, which we're going to try this. So this is going to be interesting. We've got 2 of them today. So I invite our panelists up, and we're going to focus on methods and approaching for gathering soil moisture data, just kind of continuing on with our last question. So we will have, let me get my cheat sheets here. Mike Cosh will be represented on this panel, Tyson Ochsner, and Claudia Cotton. Oh, wait, let me hold. Yep, Claudia Cotton and Peter Goble. And then we'll have, and then Rich, can we have the mic? We'll need the microphones, correct, Mike? So that our virtual audience can hear us.
Who's going to start?
We'll put it in Tyson's hand and we'll pass that. So we'll hold on. Okay, so okay, here we go. So you've heard this morning about some common threads and challenges. You know, we've talked a little bit about what forest soil moisture is and how difficult it is. And this session focuses on like, well, how do we approach that? And I have 5 minutes for each of you to roughly give some zingers and some of those highlight points. And so I've got 2 sets of questions, and we'll go with the first one. What are the top 2 or 3 challenges for gathering soil moisture data in forests? And think about your expertise when you answer that question. So Tyson.
Okay, thanks, Stephanie. So one of the challenges, so let me start with terminology. To be clear on, is a little bit tricky as we start to work in an interdisciplinary way and people coming from a lot of different perspectives. I've only been working in forest for, maybe 5 years now, so it's all pretty new to me still. But one thing I want to emphasize, so on the terminology is, first of all, forests are sometimes ag land. So I think we need to not use those as just, so my son just spent the summer in Wyoming, and he was part of his time managing grazing in the national forest. So that's ag use. So anyway, so that's one thing. Secondly, to be clear on the terminology, ag land and cropland are not synonymous. And cropland is actually very poorly represented in all of our current soil moisture monitoring systems. It's not well represented by our remote sensing products. It's not well represented by our in situ products either. And so it's hard to imagine how it could be well represented by our models since we don't have any data to check the models. So that's a big gap as well. The grasslands are what's really well represented. So I just think we need to be clear on the terminology there. So terminology is a challenge. And so I'll go to a second one, and then I'll pass it on to people that know more than me. When it comes to terminology and being clear, one of the real challenges, Stephen mentioned it in his talk, how do we talk about and how do we measure the litter layer or the duff layer or the O horizon, right? Or the transition to the mineral soil? It's a difficult thing. We need, to be very clear on what we're talking about there. And when we're measuring in the O horizon, are we measuring soil moisture or fuel moisture? And when we're measuring what sensors are appropriate for measuring in that environment, those are big challenges I want to highlight. And then.
Excellent. Okay, Claudia.
All right. Thanks. Okay, so my challenges come from more of an installation continuity of operations point of view. So just to give you the background, I guess it was 2017, 2018, we were approached on the Daniel Boone to install 2 mesonet stations. And we are doing this in collaboration with NOAA, with the Kentucky Climate Center. Many of you all probably know the former Kentucky climatologist, Stu Foster. He was in that position for a long time. He had great passion for this project, and he retired. And with that, 2 of his other employees retired who were key members of the installation. And so we've kind of had some hiccups there with the new, and I mean, anyone coming into a new position, I'm not throwing shade at Kentucky Climate Center at all. They're a great partner, but they've had some challenges getting back up to speed, and it's kind of left us, in a bit of a position, because we've got one station up and the other some things have been done incorrectly. So we're redoing some things. So I think my point here is to provide the importance of standardized protocols for installation in forested systems, and to provide for continuity of operations when this happens, because we know that people move in and out of positions, especially now, quite a bit. And the second thing is getting the data in a workable form, in an interface. So I know that was part of the original project, and that kind of ties back into the administrative problems that we've had, with this project. But I really like Missouri, even if it's as simple as the poker chip map that Missouri has. I still love that. It's so basic, but it's so informative. And anyway, I really like that interface.
Excellent.
All right.
Now, Peter, I know that you can talk about this one because we've had some challenges with forest condition monitoring.
For sure. And I think my first point would be about relating forest soil moisture data to impacts. It's a simple model conceptually. You heard Cindy talk earlier about the fact that half of the weight in trees is water weight. So we know conceptually, when we get low on forest soil moisture, that ultimately leads to lower moisture through the tree's root systems and branches and everything. And that's ultimately going to lead to things like higher risk of invasive species boring into that tree or fire danger. It's a harder model to kind of show mathematically, I think, because the impacts to forests when soil moisture is low are highly nonlinear. You can have forest soil moisture get very low and the trees start to feel that, and then maybe nothing happens, but maybe it all burns. Another thing is we don't necessarily have folks collecting that impact data. So Tyson, you showed a really nice relationship 2 days ago between soil moisture, or you used FOSS specifically, and hay yields, I think it was. Were those yield data, was that from NAS QuickStats? Yeah, and even that data source can be a bit of a mess sometimes, but we don't even have anything like that to work with in forests. So that's definitely a challenge. Then the other thing that I wanted to mention, I interviewed somebody from the Colorado Basin River Forecast Center asking about, what would it take to make in situ soil moisture observations useful in their seasonal river forecasts? What do you need there? And he was saying that really the SNOTEL stations in the headwaters, that most of them only go down to 50 centimeters, a few of them 100, or even the scan stations that go down to 1 meter, that's not really deep enough, especially when you look at the root structures in these forested areas, that he would really love at least 2, if not 3 or 5 meters. So Stephanie, when you're talking about instrumenting the RAWS stations, you're going down to 5 meters, right?
Yeah.
Yeah, and I was listening really attentively to your talk, and I heard that Stephanie does all the soil moisture installations. So
yeah, that's me.
But yeah, that's
travel budget's huge.
That's definitely something to think about, is that, it's a real challenge to either measure or model the soil profile as deep as you need in forested areas. So with that, I'll hand it over to Mike.
Now, Mike, I know you've got some special challenges with your CalVal plots and some work you've been doing in forests.
There are so many different ways to go. I always go back to the question of why are we measuring? And the first answer, there's so many things you can do with data, with soil moisture data, you say, but in reality, we have applications that need the data. And that's what we have to serve at the beginning, because they're paying for it, hopefully. And if they don't pay for it, guess what? It goes away. And there's all these, it's when my children go, hey, daddy, look what I can do. And then you do something crazy and wacky. And like, why? Why did you do that? We have to do things for a purpose because there's just not free money everywhere. So we have to design our systems right now to meet a purpose because that's who's paying us to do that. If we had infinite money, somewhere else, we have infinite resources at some point, somebody said that. We'd like to design a system that's multi-purpose, but we still have to meet that first purpose. And I'm having trouble identifying the very specific questions of, well, what do we actually need to measure? And it's not always soil moisture, it's forest moisture. It's the fuel. And I don't like saying fuel moisture because that's very, it's saying you're going to burn at some point.
Right.
I like to say forest moisture because that's where the animals live.
I hear some terminology issues with the
Yeah,
things that you're saying.
yeah, it's
Thank
very
you.
pessimistic. A fuel moisture is pessimistic.
Yeah.
So it's like calling an animal a future rug or a future carpet. So that's a big challenge is marrying that application that's paying for the thing and making it dynamic enough that it can be used and developed into other future applications, so that we can keep the data flowing, because that's necessary for everything.
And Mike, you actually started to answer the second question. Well, how do we advance the methodology for gathering forest soil moisture data? Like, how do we do that? Like, I mean, that's where we have to walk away at the end of today, is thinking about the future and how we do that. And I know we have offline conversations. We talk about it in our coordinated meetings and so forth, but we've got to take that next step. And I heard terminology. I heard capacity and administrative challenges, turnover, continuity. I heard, between you and Peter, like, why are we monitoring, and what is this data going to be used for? Like, making sure that we know our goals and objectives for all of our networks are clearly defined. And the problem is we need to know that today to answer the questions 20 years from now. And so those are some really amazing points that we're going to log from this panel discussion. But let's talk more about, where do we need to go? And so what's your ideas and your wish list? How do we face these challenges and move out? So go ahead, Peter.
Yeah, I guess I'll start since I ended up with the mic somehow. But I think that two of the biggest things for me in terms of the questions that I'd really like to see soil moisture help answer in forests are, first off, drought monitoring. Cindy talked about this morning too, how in terms of the US drought monitor and that overall convergence of evidence approach to deciding ultimately how bad things are, I think that forests are still fairly underrepresented, both in terms of in situ data and in terms of impact reports, where we get lots of impact reports from the ag sector, be it just the landowner who's calling directly to the US Drought Monitor and saying, hey, we're in D3, or if it's people who are doing condition monitoring through CocoRoss, or the condition monitor observer reports with the National Drought Mitigation Center. We see a lot more reports in the agricultural sector, or even in urban and suburban areas as compared to forests. So I know, like we've talked about, there's not as many people living in forests. A lot of the people who do live in forests are there seasonally. A lot of the work is either temporary or seasonal rather. But we need to find the people who are there permanently or looking at the same plots permanently to give us these kinds of condition updates for forests. So that would certainly be one of my points. And then the other is just when we're looking at climate change, I think forest soil moisture data and more forest data in general is really paramount, where as things warm and as weather patterns change, the adaptation measures that are most appropriate for forests are going to be really key to get right. And a big part of that is monitoring the changes as they happen.
Excellent. How much? Oh, Mike, let's go back to Mike.
Where to start is to start, which is You learn more from your mistakes. So let's start making the mistakes. I don't want to say his name, but there's been networks deployed in forests and they're learning things now.
Yes.
They're learning what not to do. They're learning which animals find which sensors tasty. They're learning how long batteries last. So you got to get started. Don't hold off waiting to get that perfect design. Let's just start throwing stuff out there.
Yeah, the
to
community
make
of
that.
lessons learned today, so we can do it right tomorrow.
Mike, you set me up perfectly because we have started with Nandita and Brianna's work on the metadata, on standardized approaches, what needs to be collected, how it needs to be done, installation, maintenance. Perhaps we can memorialize this. You know, whenever you do put mesonet stations on a national forest, perhaps we put it into an agreement with the Kentucky Climate Center, as far as specifics of who will monitor this, provide for continuity of operations. Like I said earlier, I really like the idea of mesonet stations on the national forest. I know that costs a lot of money, but I think there's a lot of value in that. However, I loved with Stephen Queering's work, the remote sensing, because that's key. We can't have a mesonet station every 5 feet. And so we've got to have solid data to be able to extrapolate out across these complex landscapes. And then finally, this is kind of the elephant in the room. How do we get NRCS to recognize organic matter in their soil profile? That is
In the database. The NEXIS
absolutely,
database that we
yes.
Go back in and
But that's huge.
Mhm.
So at any rate, those are my suggestions. Thanks.
Tyson.
Yeah, and those are all great as we think about ways to move forward. And I think one way, to move forward effectively is to better understand where we've already been. And so, for us in looking at this area of wildfire and soil moisture, that meant doing a comprehensive review of the literature. So we had a paper in International Journal of Wildland Fire last year that did a comprehensive review of the studies on relating soil moisture and wildfire. And when I, of course, came into it from a grassland fire perspective, but as we studied the literature, what was amazing to me is there's really a lot that's already been done about soil moisture and wildfire in forest, or soil moisture and fuel moisture in forest. As a matter of fact, the earliest paper that I could find linking soil moisture and wildfire was 2009, Siberian forest. The earliest paper that I could find linking soil moisture and fuel moisture was 1993. That was also forest in Australia. So there's a lot of work that's been done. It's been done and published in many different places. And I don't think we don't normally read such a broad distribution of journals. And so it's a challenge to pull it together. But if you're interested, you can find that review paper. It's got 45 studies cataloged in it about soil moisture, fire, and fuel moisture. And so one highlight from that I want to just kind of raise and bring to your awareness as an issue here is when we look at, so if we look at, for example, grasslands, which is how I got into this, we can see this clear linkage between the soil moisture conditions and the live fuel moisture in the grasslands. As Peter has already alluded to in his comments, as you get into forest, right, that relationship actually becomes weaker. The relationship between the soil moisture and the live fuel moisture in forest is weaker than it is in grasslands. But the flip side becomes stronger. Under closed canopy forest, you have a stronger link between soil moisture and dead fuel moisture under that canopy. And the dead fuel moisture in a closed canopy forest becomes somewhat disconnected from the atmosphere and can start to be governed by the soil moisture instead. And there's been some really cool recent studies out of Australia that actually started to measure the mechanisms of liquid water transfer and vapor transfer between the soil and the dead fuel. So that's, I think, a way forward is to really dig in and understand these mechanisms of what's happening there on the forest floor. And so I'm excited about the progress in that direction.
Excellent. Does anyone else want to say anything before we go to questions? Okay, all right. So you have this panel of experts up here. Do you have any questions in talking about the challenges and the path forward? Cindy in the back there, please, Rich. Oh, we've got one over here. And then Mike, are you monitoring our online questions as well? Do we have any?
Okay, thank you, panel. I mean, I made a lot of notes. Appreciate your comments, and I think they're spot on in a number of areas. The one thing I haven't heard anyone talk about is the relationship between the way trees, the physiology of trees under long-term drought conditions. So when we relate drought to croplands, grasslands, rangelands that are not heavily forested, we're looking at a process and a system that has a shorter timeline. It's more seasonal. But when we look at trees over long-term ecological drought, you have to understand the tree physiology and what happens to those trees under unprecedented conditions that we haven't even measured, right? So thousands of papers, tree physiology, how all that works in the canopy under different conditions, but that was last century. And so what we have seen is trees have different response mechanisms in the way they open their stomata, when they do, their respiratory processes, et cetera, et cetera. And this changes under these we've seen this under severe drought conditions. So there's that consideration when we're thinking about this. And I'll go back to Peter's things. What's the environmental change in condition that we're seeing? So it's not one piece of data or information. It's multiple signals within a system that start to point to a trend or flag early warning. That is probably what we really need. And to understand how trees now are responding, again, under unprecedented temperature changes is going to be important. So that evapotranspiration element, I'm wondering if any of you can comment on how to incorporate that piece of it in looking at potential fuels. Because when a tree, and we can look at this also as another metric and measure, which is tree canopy water content as that changes. So any comments on that whole biophysiology component?
I'll start on that. I'll take a stab. One way that you could potentially get at that is by forest cover. So if you're in an oak, an upland oak forest, you can expect those trees like oaks to have deep tap roots and to be more resistant to drought stress, I would think. But like down in where it's more mesophytic. So on our forest, from the lack of fire, we're seeing mesification of the upper slopes. And I think you could get at that site moisture and evapotranspiration by looking at forest types as a first cut, a very rough first cut. And I'm sorry, I'm just automatically handing it to you.
We're down to one mic.
Is some of the answer in the retention data? Because we talked about having retention data in soil water retention data in the metadata yesterday. But like right now, one of our main products is just half of the soil moisture picture, right? And a lot of these are going to be driven by matrix potential. So is that part of the answer, is incorporating that into the data set?
Yeah, that's a great direction to take this, Chris, and to connect to what Cynthia was just saying. I want to really highlight some work from one of our colleagues. Nicholas Coops is at University of British Columbia. If any of you know him, he's a forest ecologist and modeler. And they did a really fascinating study. They did the entire western part of North America and they ran a forest model. I think it's called 3PG or something like that. Somebody can correct me on the name of that model, but they were running a forest model for that whole large domain. And they recognized that one of the problems was there wasn't adequate soil water retention characteristics for these forested soils across that large domain. And so they used remote sensing of the forest canopy vegetation health to identify the areas that were when and where it was drought stressed, okay, as reflected in, for example, the leaf cover. And so then they use that to adjust their estimates of the available water capacity of those forested soils. Once they had calibrated their model that way, then they ran that forward and characterized the areas that were vulnerable, as Cynthia was saying, over the long term to fire. And then they were able to find that, in fact, they were identifying those areas where the historical fire occurrence had been most severe. So there's some really cool stuff that some folks are starting to do in that space of connecting the soil properties, how that impacts forest stress over the long term under drought, and then connecting that all the way through to fire disturbances. So
I wanted to bring back the fuel versus soil moisture issue, and provide maybe some little clarification and maybe some more questions for you. And I guess my thinking is that fuel. So that's for you guys not familiar with forestry and what we do. Think of leaf litter, horizon as one component of fuel. We also look at small sticks, twigs, branches, different sizes. We divide that into fuel, as well as the coarse woody debris, the larger logs that retain a lot of moisture. And we do measure fuel. We use raw stations to measure fuel. Foresters think about the fuel measurements as they write prescriptions to do a prescribed burn. But fuel moisture is not soil moisture, in my opinion, and they can be quite different. Tyson, you provided some link between some of those elements. So for some of the fuel, the larger fuel, it's probably very connected to soil moisture, the larger fuels, right? When we burn in oak systems in the central hardwood region, so where Claudia is working, the fuel in prescribed burns that is removed is from the organic horizon, the horizon and the leaf litter. It hardly ever consumes any of the larger fuels in that system. So we can have scenarios when our soils are dry, but our leaf litter may be moist, or some of our smaller fuels that actually are consumed in a fire are sufficient enough that we can control the fire. We think it's a good time to do a prescribed burn. And for me, I'm thinking like the month of September. The soil is going to be quite dry. The severity of that fire can be quite different. So when you have a dry soil, even though your fuel might be in a normal range of moisture conditions to allow it to be controlled, you might have greater heat penetration, greater root mortality, and even mineral soil organic matter that's consumed, and that creates a different effect, a different impact than if you're doing a prescribed burn when your soil moisture levels are greater and you have that heat capacity of that water keeping that heat penetration down and the severity different. So I just want to call that to people's attention. It may not, fuel and soil moisture may be different things. We need to be aware of that. I think we need to do more work on looking at those links. And I think it's an important distinction to make.
And for our virtual attendees, that was Dr. John Kabrick from the Northern Research Station talking.
I have a comment, not really a question, a comment on Tyson's terminology point as we're working with different communities. And several of us, a few of us were talking about this yesterday, which is that if I see VWC on a slide without any sort of context, my first thought is going to be vegetation water content, which is itself not a great term because it's not a content, it's a column density. But that's not the point, which is It's just something I kind of wanted to bring to mind is more from a remote sensing perspective, is that if you put on a slide presenting that you did additional VWC sampling was done within X meters of a station, my thought is that someone went out there and cut down vegetation, waited, told us how much water was there. It's just, I wanted to.
I want to just say a quick thing about the matrix potential, which some of the networks are putting out along with their soil moisture, and you're trying to get a fuller picture. And and going back to Cindy's comment about leaf water content, and I always have to remember a forest is not a collection of trees. A forest is an ecosystem that has many different components. It has an O-horizon soil, it has critters in the soil, it has understory, litter, and getting as full a picture possible, I mean, we have to deploy as many tools as possible to remember, to observe all these things. And we're also observing things in time steps. In those time steps, we also say, well, what happened this year, what last year? But remember that within any given year, there's an evolution and sometimes a trend in that. And if we only keep ourselves into years, we're missing decadal trends. And when I spent a lot of time in the forest recently, I was then instructed about how there's a succession of trees in forests. There's first you have these, and then these die off, and then these come in.
That's right.
And I'm like, oh, I thought just trees. They're the things on the sides of the field that shade my black caps, because that's what I really want. I want black caps and blackberries on the side of the field. So terminology is important. But understanding also this is a whole ecosystem. We're studying all these different pieces. And we can use different tools to monitor different components and bring them together using the right terminology.
Yes, we have forests that are commercially viable. We have forests that are in national parks that we don't harvest, that are long-term succession, old growth. We have clear cuts, and then we have 5-year stands, 10-year stands, and we won't even see the crop of trees that we're going to harvest for another 80 years plus. And then we have our agroforestry crops that we're harvesting every 30 years in our southeastern forests. So yeah, it's really different and successional. So I appreciate that comment, Mike. Go ahead, Claudia.
Stephanie, I'm going to repeat a comment that you made. I believe it was yesterday that, and yes, and also what you're talking about, we're talking about an entire ecosystem. I love it that Lisa brought the mycorrhizae to the table yesterday, because that is fantastic. And it just shows another level of the interconnected big picture that we need to look at that's driving these processes.
So if we write a book, we got to have biology in our book.
I just had a quick question. I'm going to direct it to Peter. Maybe some others have some experience. Citizen science and collecting soil moisture information. I remember years ago, Nolan was telling us of his efforts to try to encourage citizen scientists to do gravimetric. I didn't know if how far that effort has advanced. Do you have any thoughts to make it maybe more popular in the future? I know that baking cores of soil in people's ovens wasn't very popular at the time. I just wanted to get your thoughts if you've seen any maybe inexpensive soil monitors that are worth incorporating into CocoRa's and other networks.
Yeah, Mark, I love that question because I get to tell a story. You mentioned that 2013 Missouri meeting following the 2012 drought. I think that was where the idea of utilizing citizen scientists to measure soil moisture really was birthed. At the time, I was just an undergrad studying mesoscale meteorology. I had no idea the outcome of that meeting would come to ruin the next 10 years of my life. But yeah, I ended up as a part of my grad project from outcomes of that meeting, creating a protocol for citizen scientists to monitor soil moisture. And I remember after creating that protocol, Nolan, my advisor at the time and founder of CocoRa, was like, hey, people including OSTP are really interested in what we're doing here. Do you want to go to DC and talk about this in the Eisenhower building in the war room? And I'm like, yeah, of course, that's a great opportunity. And so that's how I initially got connected with this group. And so the appetite for soil moisture data from citizen scientists was palpable. It was great, but who didn't like my protocol was citizen scientists. So CocoRoss in recent years has more pivoted to, we're really pushing these condition monitoring reports and tell us about the impacts of the drought and tell us about what's going on in your soils through those reports, and that's been much more successful. But to get back to your point about low cost sensors, I think there are materials out there that would allow us to get a lot more people taking soil moisture measurements. I think that's just a matter of finding the right grant and finding folks to kind of experiment with these. But I think that I think we could go somewhere with that.
Okay, we have 5 minutes left on this panel.
Hi.
Okay, we'll go to the back and then we'll go to Lisa and we'll wrap that up.
Andreas Koyander from JPL. I'm leading the SMAP calibration and validation efforts at NASA. And for geophysical products, including soil moisture, we just completed this MapVex experiment in Massachusetts and New York. Run these stations from 2019 to 2022. My Cosh was responsible for the soil moisture measurements and some of the vegetation measurements. And this is, these results are one of the, recent results that's showing that we can measure soil moisture. With the SMAP mission, we are sensitive to soil moisture. So something that I hope there is, consensus growing that it is possible to do that. Then more specifically, what we do with radiometer, we can measure the emissivity of the ground and opacity of the forest. And then that information can be then translated to soil moisture and vegetation information like vegetation water content. But making that translation, we need people like people in this room who know how to make those measurements, how to understand what's going on the ground and all these physical processes and how to measure them. But then we need to connect that to the limitations of the remote sensing instruments, because we can't change the physics of the remote sensing. So there is, if someone says, oh, I need measurement at 1 meter depth in soil, there is no remote sensing measurement of doing that, but we can measure the surface and we can connect that to the deeper levels. And if we have people who understand all these processes, we can make that happen. But the remote sensing cannot magically just do that. And that's why I think it would be really important to connect the communities in the effort to find these methods to do these things. And it requires flexibility on both sides. But as I said, in the remote sensing side, there are physics that are limiting, and we need new methods to make the reference measurements that then creates the sort of the pathway to that parameter that actually needed through people who actually know how to make those measurements and understand the physical world and how they work. Electrical engineers are not those people.
More collaboration. That goes to
Yeah.
Cindy's comment. We need more collaboration and transparency. Lisa, I want to go to Lisa.
Yep,
And then
I'm going.
we are at the top. We are almost at the top of the hour. We have 2 minutes. 2 minutes, Mike says.
No pressure.
I
Give- give-
know, I'm sorry.
Give her another 30 seconds.
So I just wanted to get back to Cynthia's question for a second, and just point out a couple of things. So I didn't talk about them all yesterday, but mycorrhizal fungi are intimately connected to tree ecophysiology. So for instance, the water use efficiency issue that we talked about a little bit yesterday, just one of many examples. The other thing is that, so I've been working with a whole bunch of tree ecophysiologists and measuring things like gas exchange. And one of the things that we're seeing as the climate starts to change and we have these extreme droughts is that trees are actually putting out less dense canopies. And I don't think we've started to think about that when we think about fire or what soil moisture means to fire predictions and things like that as well. And Peter, I would love to talk to you because we actually have volunteers working with us on the project in Santa Fe National Forest. So we're going to be collecting fuel moisture, soil moisture, and mycorrhizal data. But I'd love to learn from all the lessons and experiences that you've had, and talk to anybody about tree physiology if you want to talk physiology. Thanks.
Yeah, let's talk at the break. That sounds great.
Okay, let's have Amanda put her question on the table. We might not be. I hate to limit people's questions. This is such great dialogue. This is what it's all about.
Here you go.
I'm loving this panel discussion.
Thank you. This is going back to the very basics, maybe in forest soil monitoring, but as I've been talking to folks and learning and trying to work with the ROS depot and figuring out how we can monitor forest soils when the stations are in a clearing. So my basic question for foresters are, how far into the forest do I need to go to actually feel like we're getting a representative sample?
That is a great question.
Because what I learned from the ROS Depot guy is that the Stevens hydroprobes they use can get a cable that's 150 feet long. But then I learned from Kent that, oh, maybe you put a junction box so then you can expand further. So I just kind of need, how far in do we go?
Love that question. Yes.
Take it. Yeah, I'm going. Okay.
How far, Claudia?
Okay. So we set up on the station, the Mesonet station that we have, gosh, we have a lot of sensors. And we went into the forest probably 300 feet. We have a transect from slope top to bottom on a northeast slope and a southwest facing slope, and at different slope positions down the hill. And they transmit the information back to the main tower. So 300 feet is what is the distance we went in.
Mike, go ahead.
So the first question would be, what are you trying to measure? And then I'm going to relate it. I'm going to give an answer that's probably not right, but it'll save you a lot of distance. 2 times the height of your tree, the average height of your canopy. In cropland, there's tractor rows that go around the outside of the field. And that's kind of what you're asking, is how far in do I have to go to get away from an edge effect? Well, what's an edge effect? Let's look at eddy. We're talking atmospheric correlation, micrometeorology. What's my boundary layer on a forest? Certainly within a tree length, I'm looking at an eddy. So go twice as the minimum. And that's not going to be 100 and 300 meters. So that's a start.
That's a start.
So, but think about the atmospheric dynamics of your trees and what is you're trying to measure something that's affected by the atmosphere and the micrometeorology. And then I'd worry about your canopy closure and how representative you are. So I'd use the remote sensing aspects of that to also inform your decision making of exactly where, how far in, because not everywhere is equal.
Well, John, I know we need to go to the next panel. We're like 2 minutes over. I see that this is great. Does everybody agree this panel format was okay? Like the discussions? Yeah. Okay. This is generating a lot. Well, with that, let's just thank our panelists and we'll go on to the next phase of thank you, panelists. That was really wonderful.